This is lesson 6-5, conditions for rhombuses, rectangles, and squares. And Elizabeth, my daughter, is going to be doing part of the video.
We can determine if a parallelogram is a rhombus, rectangle, or square based on the properties of its diagonals. This is taking the properties we learned yesterday and using them to show whether it's a rhombus, rectangle, or square. If a parallelogram is both a rectangle and a rhombus, then it is a square. This is because the square has all the properties of a rhombus and rectangle. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus.
So in this picture ABCD down here, it's a parallelogram because the opposite sides are congruent to each other. But if ABCD is a parallelogram, if the diagonals are perpendicular, so if AC is perpendicular to BD, then ABCD is a rhombus. And this makes sense because yesterday we learned that a rhombus has diagonals which are perpendicular to each other. So if the parallelogram has diagonals which are perpendicular, then we know that the parallelogram is a rhombus as well. Okay, the second thing is,
if one diagonal of a parallelogram bisects a pair of opposite angle, then the parallelogram is a rhombus.
Okay, so once again I have a parallelogram right here. I have parallelogram ABCD, and I'm looking at angle 1 and 2, and they're congruent to each other, and angle 3 and angle 4 are congruent to each other. So if ABCD is a parallelogram, and if angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, then ABCD will be a rhombus. So if ABCD is a parallelogram, and angle 1 is congruent to angle 2, so that means the diagonal bisect the angle, and if angle 3 is congruent to angle 4, again the diagonal BD bisect the angle, then ABCD is a rhombus. And this is another property of rhombuses, that the diagonal bisects the angle, so it makes sense that if that was true, then it would be a rhombus.
If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle.
Okay, so yesterday we learned the diagonals of a rectangle were congruent. So if I have a parallelogram, like ABCD is a parallelogram, you can see the opposite sides are congruent. So if ABCD is a parallelogram, and if AC is congruent to BD, then ABCD is a rectangle. Okay, so these are ways that we can prove our special parallelograms are rectangles and rhombuses, and then finally squares as well. Okay, and we're going to do some examples, or you're going to try some examples on your own. So I want to know, for what value of x is parallelogram ABCD going to be a rhombus? So if ABCD was a rhombus, then that diagonal would bisect the angle. So these angles would have to be congruent to each other. So you're going to set up an equation where these angles are congruent to each other, and set them equal to each other and solve, and that's the value of x that would make this a rhombus. Okay, so you're going to solve that problem. And then the bottom two, we want to know if we can conclude that it's a parallelogram is going to be a rhombus, a rectangle, or a square, and explain why. So we got two problems. We got A and B. So figure out, based on the properties that we just talked about, if those are going to be rhombus, rectangles, or squares, and explain. So you're filling out these two bottom sections and your summary sheet as well, and then that's it.